Hey guys. All right, so we're on our last video, absolute value equations, or that is our last video for 1.5. And I'll try and make it quick and not ramble at the end of this video like how the last one went. So we'll start with a quick reminder of what the absolute value actually is. So the absolute value of a number x, we can write it as sort of a piecewise equation where it's x or negative x if x is greater than or equal to 0, or if x is less than 0. But really it says if the number is positive, so something like the absolute value of 5, just give us the same number back. Or if the number is negative, so if we have negative 5, then give us the negative of that number back, so positive 5. And essentially all this is just distance from 0. So both 5 and negative 5 are 5 steps on a number line away from 0. And in this section, we introduce absolute value equations, and they actually don't involve quadratics at this point. It turns out we need to know a little bit more about quadratics before we can do absolute value equations with quadratics. But this is a good time to just introduce how to solve equations with absolute value. All right, so for our first example, we want to solve the absolute value of 5x minus 7 equals 2. All right, so remember, if inside the absolute value, if that equals 2, then the absolute value is going to keep it as 2, and we're good, we have a solution. But also there's another solution as well. If it's negative 2, then the absolute value is going to see, look, there's negative 2, that's a negative number, we need to flip it to be positive and give us back 2. So that's also a valid solution. So absolute value equations actually return 2 equations in one. So this breaks into 2 problems. So we have problem 1 is we want to solve 5x minus 7 equals 2. And our second problem is we want to solve 5x minus 7 equals negative 2. Right, so we tackle problem 1 first. So 5x minus 7 equals 2. This should be pretty quick to solve. We just add 7 to both sides and then divide both sides by 5, and we get x equals 9/5. And then for our second problem, we'll have 5x minus 7 equals negative 2. Add 7 to both sides, so we get 5x equals 5. Divide both sides by 5, we get x equals 1. So we have these 2 solutions, x equals 1 and 9/5. And we got 2 solutions here, and because we didn't square anything, we don't have to worry about checking if both of these are solutions. It's going to work out. Some absolute value problems, at least ones I like, are ones that actually have no solution at all. A crucial step when approaching any problem in life ever is asking if a solution exists. So this problem asks you to find the absolute value of 10x minus 23 equal to negative 3. Now we know if we plug in a positive number to the absolute value, it's going to shoot out a positive number. And if we get a negative number inside the absolute value, it's going to shoot out a positive number. There's There's no way this can equal -3 ever. That just falls out from how the absolute value is actually defined. So therefore, we say there is no solution. And I'm likely to test you on a problem that looks almost exactly like this one, because I think it's just a very good skill to be able to think about if there even is a solution to the problem before trying to solve it. And that's really all there is to absolute value equations right now. I hope you enjoyed section 1.5. There is homework for the section due Monday. And good luck, and just do a lot of practice problems. This stuff really becomes easy with a lot of practice. All right, see ya.